Hello, I'm Miro Blaško, as a member of KBSS group, knowledge-based system and software group, and I will present today some lessons learned from development of system for safety and reliability of aircraft. We developed the system together with our partner AERO Vodochody AEROSPACE company. The presentation will be as follows. First, I'll just state the goal of the project and describe software architecture, and then I will describe a role of our tools within the architecture, and then use of third-party development tools. At the end, I will demonstrate a system. This system is currently under development and should be developed very soon, in about a month. The goal of the project is as follows. Our main goal is to provide aircraft with analysis. The main focus is on reliability, but also on the safety. We have aircraft, and we represent aircraft by the model. The model includes the partonomy of components, functions, failures, and their relations. And based on such a system description, we are able to generate some kind of analysis. Another part of it is data collection. We integrate multiple sources of data, operational data, but also we include in the system description data that comes from manufacturers. For example, some kind of failure rate of separate components, or availability of components, that is how long does it take to deliver new component, or similar stuff. And in previous project, we focused a lot on this part. So generation of analysis from system description. So here is a picture of so-called FTA analysis, fault tree analysis, which is a top-down approach to tackle critical or tackle failure events, or events that might cause some kind of damage to the operator of aircraft, whether it is just some additional repair, or it could cause a life or something like that. And FTA analysis is a way how to analyze those events by splitting them into sub-events that happen on different subcomponents or subsystems of analyzed system. And the tree combines, the tree is attaching probabilities to those events and using operators to decide how to combine those events. So, for example, here it says that electrical line failure or mechanical failure will cause loss of the engine 1 pressure air. In previous project, we focused on this arrow to generate such FTA analysis automatically or semi-automatically. And within this project, we focus more on data collection and providing rather probabilities for the FTA trees while not generating FTA trees. Beside that, we also provided some other statistics related to safety and reliability as a Pareto diagram and others. This is the architecture of our software. Basically, the AVA company is something that we call supplier because it is a company that creates or manufacture aircraft, and there are some clients of this supplier which we call operator, and those are the ones that operate with aircrafts, and they report what are the failures of aircraft, or what are the issues related to the aircraft operation. And the system is deployed on both operators and suppliers. The system that we developed on the operator side, the main role of the system is to collect form-based data. For this, we have a component called Record Manager, which is a domain-independent application whose parameterization are the forms to collect, and those forms are defined declaratively together with the logic how the form works. Also, the other domain-dependent modules that we had to implement are some kind of report module and export module. So whenever operator collects data, he wants to also generate some reports of collected data or export to the supplier. So within the operator organization, we differentiate two roles. One role is data entry technician. This is the person who enters failure records and edit or close the failure records when they are done. And then we have some role called operator admin, which is the role who sees the statistics of failure records, as well as manages communication with supplier in sense of updating forms when needed, or updating possible values of forms when needed, or uploading the failure records to the supplier. We have basically two cases of that, offline and online mode. For online mode, we have integration with Keycloak. So we have on both infrastructure, on supplier and operator infrastructure, we have Keycloak instance, which can be connected together to support automatic deploy of records, while also here pictured in the red, we have workflow to do it manually. So that's basically actions related. Those are actions related to operator. And on the supplier side, we have very similar workflow, because there exists there are some roles. There is role record validator, and the record validator is a person who gets records from operator and validate it. Somehow, the main goal is to either approve or reject the form, and another goal is to classify failure records to some FHA, functional hazard analysis concept, so it can be used further for FTA analysis. Also, the supplier is able to see some statistics similar to operator, but also extended statistics based on multiple other organizations, so all the operators, and has also different export models. But basically the structure here you can see is very, very similar. I mean, basically the same. The record manager is used to basically import the form from operator, extend it with additional questions, and also it provides the workflow of accepting, rejecting, publishing records. Beside that, the additional module for supplier is FTA FMEA tool, which is used for modeling those trees, and the input is taken from the failure records, those statistics that are then attached to some nodes based on the failure records. Beside that, it is quite dynamic in sense that the supplier organization can create new forms, can import new taxonomy of aircraft, can import new FHA failure rates. So the goal of this role, which is called reliability modeler, is to also import and update components of aircraft, their failure rates, their availability, and so on. The last role here is the supplier admin, which just manages users, as well as the internal user, as well as operators. In case of offline scenario, he manages just some roles for internal usage. This is more functional decomposition. Here is, I would say, rather more structural decomposition of the system. Here is the structure of Docker services. We have all those are services. We have this is one instance, but it could be also separate instances. But this is one instance, and each rectangle is another instance as well. So basically, we can look at the services this way, that both supplier and operator shares the same services beside this FTA tool. While there are 4 different databases, we have the database is TripleStar. It is GraphDB, OntoText GraphDB database. And Record Manager uses 2 databases. One of them is for management of records, while the another one is for management of form definitions. Then we have The role of record manager is management of records, but also it tracks the provenance data, the history of actions. It also enables to import the code lists or the possible values of the forms and so on, while also provide some basic statistics. But for our case, we need some more advanced statistics that are not general enough. So there is some module for that, which we call AVA Analytics. And we also use it to import some of the code lists as they are very specific to the application. Then we have Keycloak. Yeah, the arrows here are to state which services are managing or which services write to those repositories, while those two services are currently writing to the repositories as well, but it should be at the end re-implemented. So some of those lines really means that the write access, although this is something to be changed. So basically, SPipes engine plus model. This is an engine that runs ETL scripts, ETL scripts that are the pipelines defined in RDF, and it uses ontologies as input. So it is basically, it uses some kind of model repository that defines the domain ontology as well as some kind of reusable modules defined in RDF. And SPipes script looks like this. This is a script that demonstrates how we import components of a system. So the supplier is working or is holding an Excel of their components. Those components are hierarchically organized. They have many attributes, as I was mentioning, like failure rates, probability, criticality of components, the required probability of components, or relevance to ATA taxonomy, and so on. And this Excel is through this pipeline somehow imported. Here is the Excel. Here is a selection of system that we want to extract from the Excel. This pipeline works to import all the systems or to import one system each time. So what we do is we take a CSV or Excel file, we do RDF representation of it, we check input schema, we infer row-based attributes, which is basically there are some missing values within Excel, which we supplement before processing it further. Then we construct components, taxonomy. Then we infer some taxonomy-based attributes. Then we check for invalid external entities. Since we allow to re-import through Excel partonymy of aircraft, we need to make sure that we don't break the systems, or we don't break data within those tools. So we don't break data within separate tools. So before we import, we need to check that the entities that are used won't cause break of the system. So for example, let's say you have some kind of component which is already used in FTA3, and you delete the component within the Excel. So this is some kind of check that it won't cause the issue. The other issue could be also in form collection. If you delete a value, some code list value, and it is already used within the forms, then you need to either fail or need to do some workaround how to either ignore the value or somehow disable it. So this is the role of the role of this pipeline item or pipeline node is to check this, and then to construct relevant models for each I would say database. Let's say we want to construct possible values for the forms to collect. We want to construct a code list for statistics, which is also different because, for example, for form collection, we use separate taxonomies for each aircraft, while in statistics module, we use joint taxonomy of all aircrafts and their components. So the code lists or possible values looks different. And then we need to construct system description for the FTA tool. We need to describe the not only components, but their functions, failures, and so on. Also, for some cases, we need to mark invalid entities. More concretely, we need to mark those FTA trees which used components that are not that were deleted or somehow remodeled. So within the FTA tool, user should be able to see invalid FTA trees which he or she should remodel. For the analytics model, we need to compute additional statistics if the metadata of components were changed. For the SForms, although this is not currently applied, we could change is relevant if rules. Those are the rules of filtering the forms, which based on some model, we could filter some value. So whenever user selects a value of one, he answers one question, the other question, the answers of the following questions could be filtered. So this is something that could be part of this pipeline as well, although this is not implemented. Currently, as I said, we access it directly through some technical debt we have. We deploy those models directly into separate context of GraphDB repository, although this could be done rather through import of those tools. So that's a use case for our tool called SPipes. We recognize the following challenges, and we improved it in this project. So we added support for Excel because we had support only for CSV. For the tabular model, we added support to deploy multiple contexts. The way it is done is while SPipes operates only with pipelines using triples, those triples are annotated before they are They are given to RDF4J module. They are annotated with triple stating to which graph the triple belongs, and this stream is then deployed to the specific RDF repository. We extended reports of validation constraint errors to be more concrete. When the pipeline fails, for example, we check input schema and we find out that there is missing column within input data, or the value is not integer but something else. We need to report to users, so the SPipes should return some kind of error. So also this happens. We have many validation constraints for each node in the pipeline. So each node can say some input constraints and output constraints, and if those fails, the whole pipeline fails, and the output is thrown to the user, and it is shown. So since we have RDF representation of CSV, we can also typically state to which row is causing the issue, and so on. So this is how it is done. Or here we can say, for example, here we can say which entities are used within other applications, and to which row they are relevant to. The other idea is, which won't be implemented, but the other idea or things to improve is to provide transactions here. So for example, if we would go with this procedure, we want to deploy data to 3 different RDF4J repositories. So we should have some kind of module to start transaction, and then some kind of module to commit all those transactions if everything is going well. So this is another idea to implement. So that's all about SPipes. The record manager, as I said, is this generic tool to manage records, and SForms is a tool just to show the forms and to fill in the forms. Fill in the records, but through declarative definition of forms. So what was changed is we added some validation support while we are differentiating 2 things within the form. Sometimes you need to save the form just to save the required questions, and another use case is that you need to complete form for some use case. So within the form, we differentiate 3 different questions. One of them is optional, another one is required to complete the form, and another one is just required question, required to save. We also added a component. So for example, a component a component for answer of the question, which shows autocomplete tree of values. Then we improved some components. For the communication with the client, it is very useful to export definition of forms to some textual description, so he can comment on it. So we have a way to export the declarative definition, which is in RDF format, to textual format, which then client can validate or can add the suggestions. We were also thinking of providing more generic use case this. So, for example, if you have multiple roles playing within the form entering, some people fill in some parts of the form while other people fill in another part of the form. So we were thinking of adding this generic way of specifying which questions are required for which use case, basically. The record manager was extended to provide some workflow over records. So we have the states of record being open, valid, completed, accepted, rejected, published records. Also support of validation, support of pagination, and filtering of records. Then we are able to import, export records to JSON and Excel. Importing and exporting is partially done. The other tools that we use, KBSS tools that we use and are available for public are JOPA, which is Java All Persistence API. It is similar to JPA, and it maps ontologies to Java model. It is also able to generate Java classes from all ontology as well. For the REST API, we use instead of JSON, we use JSON LD, which is extension of JSON towards linked data, and we also have a library that is doing that. And for the Keycloak integration with RDF for the databases, we have this Keycloak GraphDB user replicator, which basically adds users' metadata into GraphDB repositories. The use case is that we want to manage users in Keycloak, but we want to have metadata such as first name, last name, or maybe even email address. We want to have it available within the application, so they are somehow deployed to the repository, so they are triplified within the repository. Regarding the use of third-party development tools, we use GitHub multi-repository projects. We use some tags for Scrum sprints. We use some attributes also for estimation of work, time estimation of work. Then we use Figma to design wireframes, GitHub UI to merge PR, although we are using it only partially because some use cases are not supported by GitHub UI that we need. We need something that we call rebase plus merge feature. Then we use Docker Compose for orchestration of services, GitHub Action to deploy Docker images. We deploy for main branch, but also for each PR. For the library components, JavaScript library components, we use Netlify and Storybook, which is also deployed per each PR. So within each PR, we can test it. Also, we use Maven and npm.js to deploy software artifacts. So there is a lot of things to discuss here around use of those tools, but to be short, let's cut it here and let's go to demo session, while we can come back to discuss any interesting parts of those tools that we use. So that's it. Thank you very much. And we switch to demonstration, which unfortunately will be private.